So we have plus HCN. It's actually HCN that it reacted with. Now when these two things react, this CN here is negatively charged. So it has the tendency of coming up here. Then this one come up to form O negative. Now the hydrogen will combine with the O negative to form OH. Is that okay? So the product of this reaction will be something like this. Of course, you have your OH here. You have your OH here. Here will be COH. Here will be H. Here will be CN. Plus, okay. Now, at this point in time, what do you think we can actually do? I can rearrange this, right? If I rearrange this, it's going to come out this way. Here will be OH. Here will be OH. Here, you are going to have your OH normal. And then here, you are going to have your CN. Here will be hydrogen. Now, if you reduce this by putting in the appropriate reducing agent, all right, if you reduce this reduction, now what do you think will happen? This CN will be reduced to amine, primary amine, because CN are capable of being reduced to what? To amines. So this one will be reduced to amine, which will give us something like this. Here will be C, OH. Here will be our CH, normal CH. And then here will be CH2. Here will be what? NH2. So this is the structure of noradrenaline. Noradrenaline. Alright, what is the structure of adrenaline? This is the structure of adrenaline that we just synthesized. CO, which is CHO, correct, CH2, NH, CH3. So you see the difference between adrenaline and non-adrenaline is that the CH3 here is not there in non-adrenaline. Alright, the synthetic mechanism is quite different. Alright, outline the synthesis of pyridine. How do you synthesize petidine, rather, not pyridine? Petidine. So how do we synthesize petidine? First of all, what is the structure of petidine? So for petidine, we have the structure like this, right? Say 4-phenyl piperidine. Abina. And then you have your COO, C2H5. This is the structure of petidine, which is also known as what? Piperidine. So how do we synthesize this compound? Yes. What is the starting material for this synthesis? Is benzyl cyanide, right? So we have the benzene ring, which is something like this. Then you have CH2CN. This is benzyl cyanide or benzyl cyanide. So you come here and write it down. And bis 2-chloroethyl methylamine. Now what is that structure of bis 2-chloroethyl methylamine? Something like this. You have chlorine group plus chloro group, CH2, CH2. You have another chloro, CH2, CH2. Alright, and then you have all this connected to nitrogen, and then you have CH3. Alright, now at the end of the day, what do you think will actually happen here? It's very easy. This chlorine and this chlorine group We remove these 2 hydrogen from here. Are you getting it? To form 2 hydrogen chloride. And then there will be a linkage between this group here, this CH2, and this carbon here. Not the CNO. This carbon. There will be a linkage. So it's going to form another benzene, pyridine. If you count, this is going to give us something like this. If you want to go that way, that will give us something like this, which is then you have your this carbon here. Then you are going to have another carbon here. That is 2 carbons, 2 carbons. This carbon here is this one. This carbon here is this one. This carbon here is this one. Then you have something closing in, then CH3. Alright? This carbon here is this one. This carbon here is this one. Alright? Now, this will now give you a structure. You know the CN, we did not say anything concerning the CN yet. Alright? But the CN will definitely be on this carbon here. Alright? The CN will be on this carbon here, which will now be our CN. So you hydrolyze the CN. Hydrolysis means H3O+. When you hydrolyze CN, we can now we can turn this structure so that it will be a straightforward structure because of space. It's still the same thing as something like this. Okay, there will be no ring here. Here will be CH3. Told you if you hydrolyze this CN here, hydrolysis means conversion to maybe carboxylic acid also or alcohol. Whenever you hydrolyze Cr9, it gives carboxylic acid. So what we'll be having here is a carboxylic acid group. Is that okay? Now, to get the ester form of this carboxylic acid, because what you need is the ester, you now react this with what? Ethanol in H2SO4. So you have C2OH in what? H2SO4. This will now cause esterification between carboxylic acid and what? Ethanol. And esterification between carboxylic acid and ethanol will give us something like this. Alright? So this is the expected product. This is the product we are expecting. Here will be COO, C2H5. So this is your meperidine or what? You can either call it meperidine or you can call it what? Petidine. Is that okay? So that is how to synthesize petidine. Now synthesize probenicid. How do you synthesize probenicid? Probenicid is a uricosuric agent. What is the structure of probenicid to start with? Structure of probenicid is a benzene ring. Alright. You have a benzene ring, which is benzoic acid. And then here you have S, double bond O, double bond O. Then here you have N. Then attached to this N, C4, H9. Here is also C4, H9. So we want to learn how to synthesize this compound in a very simple way. So how do you think we can actually synthesize this compound? What? Huh? You can start it with benzoic acid, but then is it just benzoic acid? Or we can actually start with amino benzoic acid. Then you react it with this is supposed to be This is, are you sure this is the structure? Let me think. C3H7, not C4. Alright, so we have C3H7, here C3H7. Now we have to start. You can start with benzoic acid, but I would actually love us to start from aminobenzoic acid. So we start with aminobenzoic acid, which is something like this. Alright, so we have benzoic acid. Here is what? Aminobenzoic acid. Once you know the starting material, you should know what is following next. Now you can now react this with sodamide, sodium nitrate, and HCl to convert this. You know the use of sodium nitrate, diazotization agent. So this will now form a diazole, which will now be something like this. So here will be what? COOH. Here will be what? N Abby. Then yeah, this is what is going to give to us, because this is going to form a diazole. Now after getting the diazole, the next thing is you now react this with SO2Cl. Somehow I really don't understand the mechanism of action of this particular one, but somehow the diazole was replaced by this SO2Cl. So you now have something like this. So we have the benzoic acid. Instead of us to have N this thing here, what we are now having here is what? SO2. Are you getting it now? SO2, and of course Cl, especially SO2. SO2Cl, SO2. Supposed to be SO2 something, SO2 something, Cl, yeah, SO2Cl is correct. Now this SO2Cl, what will now happen is it will now react with this part. We now have to introduce this part into the structure. Introducing this part means we will need what? N, C3, H7, C3, what? H7. With what? Hydrogen. So that the hydrogen can react with this. So that at the end of the day, when this O something reacts, you are going to be getting COOH. Here's what? SO2, and then this group attached, right? Which we can also write as what? You can write it as what? N bracket what? C3 S7 then 2. So this is the structure of your Proen acid. Proen acid. Alright? This is the structure of your Proen acid. Now the next one, ibuprofen. Synthesis of ibuprofen. Now how do we synthesize ibuprofen? It's very easy. Ibuprofen, we will be needing the starting material, which is what? 2-methyl propylbenzene. Is that okay? Which is something like this. This is CH3. Here is also what? CH3. This 2-methyl propylbenzene. Plus what? Plus CH3, C double bond O, Cl. Via what kind of reaction? Friedrich-Krafft acylation reaction. Alright? So here will be what? AlCl3. Is that okay? Now, at the end of the day, what do you think will happen? The Friedrich-Krafft acylation suggests that this Cl will leave, and then this other part will be attached to this ring. So we are going to have something like this, and you have something like this. Here will be double bond, and then here will be what? CH3, CH3. Then here will be what? C double bond O, CH3. Is that okay? Now, but at this point in time, this is not what you need. Now, so what do? We now react this with what? HCN. Abi? Now this Cn is a nucleophile. What will nucleophile do? The nucleophile will attack this position, bring this one up. So here will be O negative. This hydrogen, you know when ACN breaks, it breaks into H plus and what? Cn negative. The H plus will now attach here with OH to form OH. So we are going to form a cyanohydrin. So this is going to give us structure like this. Then we have the benzene ring. Alright, and then you have CH3. Here's what? CH3. Then here is what? C. Here will be OH. Here will be Cn. Here will be what? CH3. Is that okay? So you are going to have a reduction where this group here will be reduced. If you reduce something, it means you are removing what? Oxygen and adding hydrogen. That is, if there is, so in this case we are removing oxygen because there's no hydrogen to actually remove here. So you have reduction reaction. Now what will be the product of this reduction reaction? It's going to give us something like this. Alright, this will be C. There will be no more O here. OH. I mean, there will be no more oxygen here. Are you getting it? So here will be CH. Here will be CH. Then you are going to have what? CH3. Which is this CH3? And then what are you going to have here? Cn. Because this definitely means removal of what? Oxygen. Reduction means removal of oxygen. So you see you have your CH3. CH3. Alright. Now, at the end of the day, there will be hydrolysis. When you hydrolyze the cyano group, it's going to give us a carboxylic acid. So this is going to give us something like this. Don't mind my benzene ring. Of course, we have CH3, CH3, then this group here, then CH, CH3. Here will be what? COOH, which is ibuprofen. So this is the correct method for synthesis of what? Ibuprofen. Huh? Ibuprofen. Is that okay? Now the next one is diclofenac. How do we synthesize diclofenac? First of all, what is the structure of diclofenac? What is the structure of diclofenac? Now diclofenac is the aryl acetic derivative. So it's something like the CH2 COOH. There you have the benzene ring, make it aryl acetic derivative, and then you have this other benzene ring here. Then you have Cl. This is the structure of diclofenac. Alright? So how do we synthesize diclofenac? What do you think we can actually do to synthesize diclofenac? Now the synthesis of diclofenac starts with something like this. Think if I'm right. Then you have here will be Cl, here will be Cl. I'm trying to get it right without looking at any book. So what do you think we are now having? You now have plus, there's another group here, CO, Cl, CO, Cl. Is that okay? So that at the end of the day, where is this nitrogen now coming from? It seems there is a nitrogen before. I think there is a nitrogen here. something like this, because you have to be thoughtful. This chemistry, I think there's a nitrogen here. All right, this nitrogen is carrying hydrogen. Is that okay? So when this now combined with this, it's going to give us something like this. I'm playing around it, if I can still remember, because here will be N. One of these Cl we attack here, right? So we'll be having something like CO. Here will be what? CO, Cl. And then you'll be having this ring here, Cl. Here will be Cl. Now at the end of the day, we are going to form another membered ring, more like I know you are going to form another membered ring attached, C double bond O, then another C double bond O, then there will be hydrolysis to now give us the correct compound. I know this one will now proceed. Let me try if I can still remember. Still trying to remember. I looked at it, but I not really focus on the structure very well. If you can think for me, if you've known it before, just help me think. All right, so here will be Cl, here will be Cl. I know there will be something like this here, and then another structure like this. Here will be C double bond O, here will be, okay, there is no, this nitrogen will be part of this structure. Yes, I can remember that this nitrogen will be here, right? And then you have something like this. May this not go off. I had the laptop take low just now. Here will be Cl, here will be Cl. There's another double bond here, right? Abi? There's a double bond here. So there will not be hydrolysis. Okay. Wolff-Kishner's reduction. Wolff-Kishner suggests that if you have a ketone group here, this group can be converted to alkane by the Wolff-Kishner's reduction. So you're going to have something like this. Then you have N. Here will be double bond O. There will be nothing here again, because I told you that the Wolff-Kishner reduction is capable of converting this C double bond O to what? To CH3. I mean CH2. So that is the reason why this one here is not here again. The double bond that was here. And then of course we have our other ring. Now note that this is a cyclic amide. It can actually be hydrolyzed. If cyclic amide are hydrolyzed, it's going to give us the amine group and carboxylic acid. Are you getting it now? Because what form amide is a combination of carboxylic acid and what? Ammonia. So when this is hydrolyzed, this is now going to give us something like this. When we talk about the hydrolysis, we mean this group here will break. So here will give us NH. Is that okay? So here you have your what? N. Now this group here will be converted to carboxylic acid. But here it's also having CH2 here, right? So we have CH2, COOH, which is the carboxylic acid. So you have something like this, CH2, COOH. And then of course you now have this benzene ring with your 2 chlorine. Now this structure and this structure, they are the same. It's just the way the benzene ring and every other thing is. You see this group here, CH2COOH, is auto to this nitrogen, which is also auto to this nitrogen. This Cl and this Cl are auto to the nitrogen, which are also auto to this nitrogen. So this is the synthesis of diclofenac. It's something I just looked at randomly but I was trying to process it in my dream when I was sleeping. So that is the reason why I was able to just get it from here. All right, so that is the structure. I think that is the end of this lecture. Thank you very much for your time. We'll see you in the next one. Bye bye.